Okay, hello. There we go. We are live, I guess. Um, what are we trying to do now? Um, we're not trying to do like anything too ambitious. Um, I was honestly just partaking in one of the um um what do you call it? I mean, this whole thing. It's there's gonna be multiple what do you call it? Like layers to the screen. Because like to be really honest, um, there are some things that I um am struggling with, and not to like be the Debbie Downer here. Um, I you know what? Let's just get started. Let's do something, right? Like let's maybe read something. Perhaps let's even make something. Perhaps let's even break something. So what would that be, right? So let's you know what? Let's do one thing. Go to break, and then we'll ask it. We'll ask perplexity. Hey, I Freeman, can you please tell me some busts I could do? I want to maximize learning, productivity, EUCTIVY, VITY, productivity, natural learning, productivity, and resourcefulness. That's a new word. Now spell it. Resourcefulness. Okay. My skill set include programming, computer, uh, basic ethical hacking, machine learning, and other areas of science. Love science. I mean, I gotta say that. Um, so let's see what it tells us to do. Um, Build a machine learning model to detect phishing or malware patterns in real life, in real network traffic or emails. Showcase the progress live. Okay, that's something. Automate vulnerability scanning using Python and ML to prioritize discovered system weakness. Tackle AI versus hacker. Set up machine learning tools and bypass them using ethical hacking techniques, explaining each step. Create your own penetration testing tools from scratch. Yeah, custom port scanner. That would be nice. That would be nice. Okay, let's do that. So let's do that. Uh, not this particular thing, but instead we'll focus more on like wireless network security, because I did wanted to like make a something like an air crack suite, but I mean that's like years of what do you call years of work being spent into making those tools, and I of course can make it in like a day or maybe like in one scene. So it has to be like a an ongoing thing. But I did wanted to try it, and this seems like a good opportunity. CTF, you could do CTF, you could do a CTF, or you know what? Let's do something even more beginner friendly that I also know, like I have already had my hands dirty with. Um, I was thinking of something like an MNIST data set trained. But that anyone like everyone's done that. Should I do that? Let's do that. It's not gonna take too long. I know that for sure. Um, okay, I was gonna minimize this thing. I minimize this thing. Minimize. Okay, there we go. Uh, Now via that, via this. Okay. The projects, and then we'll see what our projects are. I also wanted to do something with attention, so that was also good. Um, so many things, eh? Or we could just learn Rust, right? Let's learn Rust. We could learn Rust. Rust learning would be fun. Um, I'll do that. So, up, around Rust. I think I was on chapter three, but just for the sake of it, I'll start again. Projects, and let's call it here, R, learn Rust line, CD learn. What else? Oh, learn lean for, yeah, that. Rust line. Here, do I have Rust installed? Let's quickly also make this bigger. Clear. Kernel protocol. Uh, Protocol that we're going to be using is HTTPS. We're going to say we also need a transport layer security. Let's see the version 2.1.2, and we're going to do rs. No, yes, rs rust sh, or well, I think it was sh rust rs. Then we pipe it to our shell. Okay, and we cross our fingers and we hope this works. Um, okay, seems like that's working. Custom. We don't need custom. Okay, let's just do this. Delete and dump, dump. For some reason, I couldn't type. So yesterday I had an interview, and well, it kind of went like it was good, but I kind of messed up the well, I'm not saying messed up. I should say fuck up. Okay, this is not a kid's thing. Okay, so yeah, I kind of fucked up the coding part a little bit. I was able to like get through the through the understanding of like what I was supposed to do and how I was supposed to get there. Um, the issue was that I just couldn't code it out. So I did. So I do now want to maximize my learning in that aspect to like be able to think of something and also be able to like code it out. But yeah, I'm not gonna take it too hard. Like I'm just gonna go with it and learn it. Um, okay, so let's continue. In production, I think this is before. Da, 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 da. Also, I've read this, so that's why I'm not reading it again. Um, Although I should. Uh, should I? No, I think I'm gonna skip the this part. I've read this part. If anyone's interested, it's just like go to this URL. Um, and yeah, read it. So yeah, moving on. Getting started. Installing Rust. We already did that. Let's check Rust. See version. Version. Okay, and Rust up. We have Rust up. Of course, we have Rust up as well. Okay, working offline. Da, 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 da. Okay, and then MTDR. Because I've also done Hello World and Rust before, but I'm gonna do it again. Rust up. Um, Rust up. No. Cargo. New. Uh, Oh, right, because in this one we don't do cargo because cargo is not introduced yet. So cargo is like the equivalent of let's say apt or brew or pacman or some package manager, and it's literally just there to install different packages via a centralized repository. So that is it, but that is not introduced yet. So in the first chapter, they're just asking us to literally make um, hello world program. So all the Rust um, file extensions are RS. We'll just touch hello world RS, and we're just gonna write something into it. So def, no, not def, function. So fn is the keyword, function main. We're gonna do um, println, and this is a macro. Okay. So now the thing to know here, uh, to note here is that the difference here between like main and how println is described. So instead of having sorry, let me just also quickly comments plus yeah. Um right. So instead of writing like println hello world, notice how we're using a not because println is a macro. Okay. Right. So println is a macro. What is a macro? We don't need to know that right now. If you're coming from like C or C++, macros are basically predefined methods or blocks of code that accomplishes um, some utility, and so they're predefined, and so the user could use it at their convenience. So this is the initial. Uh, Let me also just make this here. Tab right here. Okay. Um, right. So this is our hello world, and now we can do Rust C. So Rust C is Rust's own compiler. I haven't had a chance to look more into it, how they do their compilation. Uh, I think it is sort of like getting translated by something like an LLVM into uh, like an intermediate representation. Um, so it is that sort of an architecture. As far as I'm aware, I'll have to check it. Um, but yeah, so let's save this. We go back here. We do hello world. Oh, we go to Rust. Hello. Okay, and we're going to make this a little tab bit bigger. Clear. And then we do uh Rust C, and we just compile it. So our code's producing an error. So what is the error? Main function not found in crate, low roll. Oh right, main the spelling is wrong. So the thing about like Rust uh, code is that to initially get into to execute something, it has to like the first thing that executes is the main function. So remember that. Um, and so if you spell it wrong, like I added here, you're going to get an error. Okay, Rusty, hello world. It does not print anything because we're just, remember, we have just compiled it. We haven't executed it. So it's sort of like we have built it, but we haven't ran it. Then we do target, or it just goes here. Okay. On running it, we get the hello world, or we could just do um, hello stupids. Ah, I can't even spell it. Stupids. Should I call these stupid? No, let's not call these stupid. Hello world is good. And then see, since well, if we were to make some changes, then we would have to recompile it, and then we would also have to, well, of course, rerun it to see the changes. But as we move forward and go to the next chapter, well, we're gonna see how Rust up, the utility that Rust provides, does this for us. So it does a dynamic build. That means that anything that we have changed, anytime we run that particular command, Rust up, you know what? I'm not gonna explain it right now. We'll just go through it and we'll learn it together. So, okay, as you can see, once you compile it, you get two things. And right. So since also another thing is that since I'm on Mac OS, some of the files that I get after compiling is going to be different than if you're on a Windows machine. Just because Windows is a different has a different assembler. What do I mean by an assembler? Well, so there's a processor. All the computers have a processor. Um, what a good picture, man. Come on. Yeah, something like this. So all of the computers have a processor, and all of the processors have their own set of instructions that they adhere to. Um, and uh, the ones using Windows are usually like x86, um, using x86 assembly code. Whereas most of the Macs are now using ARM assembly, so uh, the assembly language that they adhere to are different, and so how their programs are compiled is also different. So, anyways, moving on. I hope that was something useful that I just said. Okay. Hello, Cargo. Cargo is Rust built system that package Rust built system and package manager. Most Rustaceans, it's like crustaceans, but like crustaceans, because like I don't know, there's some sort of fascination going on with like the what do you call the what are these people called? Hard shell creatures are called, or external skeleton, exoskeleton creatures are crustaceans. Yeah, right. So, but they have like a genus or thing. What is their genus? Is it Anthropoda? Anyways, we don't need to dive into it. Most illustrations use this tool to manage their Rust projects because Cargo handles a lot of tasks for you. So see, that's good. Such as building your code, downloading the libraries your code depends on, and building those libraries. You call the libraries your code needs dependencies. The simple Rust programs, like the one we have written so far, don't have any libraries. Okay, sorry, don't have any dependencies. So the the meaning of that sentence is that to compile and to execute um, these three line of code, there is no other piece of software or other piece of code needed in order for this to work. So that is what they mean by dependency. In case that wasn't clear, uh, if you had built a Hello World project with Cargo, it would only use it would only use the part of Cargo that handles building your code. As you write more complex Rust programs, you'll add dependencies, right? So what they mean by dependencies is that As you start building more and more complex things, there's a need to add more and more code that isn't truly yours, that someone else wrote, uh, but you're using it because it satisfies your need, and so you're just like using it, which is like, I don't know, like that's what happens when you're building large scale software. Um, okay, anyways, you add dependencies, and if you start a project using Cargo, adding dependencies will be much easier to do because because the vast majority of Rust projects use Cargo. The rest of the book assumes that you're using Cargo too. Cargo comes installed with Rust if you use the official installers discussed in the installation section. So we skipped over the installation section, but it is essentially like they have told us to like just literally uh, do this command right here. Uh, that is what they like ask for. Uh, essentially. This. Okay. What's going on? All right, this is not running. Okay. Okay. So that's what they've told us to do. In case you want to understand what this command is, so curl is is another utility provided to us by the good people at GNU Linux and at FreeBSD. Uh, so transfer URL. So C curl or C URL is how I say it. So it just that's how I remember it. To like see any URL on the web, you basically use curl. And if you don't want to use curl, well, you could use wget. But wget kind of sucks sometimes. That's what I've heard. I've personally never had to use it because uh, that statement was enough to like sort of not get me on that track of using wget. But wget is another thing that people use. I just don't have it installed right now. But it's kind of the same utility. Um, so we do curl to connect to, or not even connect. We do curl and then a website. So let's say if we were to do curl and do my website, kpromar.com, you literally get the content, okay? And then we could, if we wanted to do, let's say, store this, we'll just do uh, -o and then write the um, file we want to store that in. So kpromar.html, if I run this, then I would have a local copy of the website's HTML file. So I hope that's clear. So moving on to what the next flag is, this is called proto. So proto is basically defining the protocol used to connect to that website. So notice how when I was doing kpromar, I wasn't specifying uh, that's specifying. Is it specifying? I think it's specifying. Uh, me and these pronunciations are getting out of hand. Um, anyways, so I didn't I didn't even need to like declare any protocol in the URL itself, URL itself. So I didn't have to do this, or I didn't have to do this, or I didn't have to do what are some other mail to. Um, if wrong example, I didn't have to do this or this. Okay, and that's only because my website is configured so that the fallback is basically to the www.kpromar.com, and that is operated on a hypertext transfer protocol. Um, and so that's how it is configured. But sometimes some websites have it configured so that when they fail to an HTTP instead of an HTTPS uh, variant. Or what I mean to say is that if a particular website, let's say The website is something like HTTP HTTPS google.com. So just in case if the server isn't configured for the secure protocol, sometimes the fallback uh, happens to the regular HTTP protocol. And what that does is essentially makes our whole connection to the website insecure. Um, insecure or unsecure? Insecure versus unsecure. Okay, insecure. So that is why we are using a strict protocol. So even if the fallback happens, we're not going to be able to establish the connection. Okay, so if we were to not specify this proto flag and just use it willy-nilly and just do like HTTPS rust up .sh rust up dot rs. If we were to do this and if the HTTPS connection failed, it would fall back to HTTP and the connection or the bit streaming and the bit transferring would happen over the insecure protocol. That is not good. Because what if someone else uh, is doing like a MITM attack, like man in the middle attack, which is quite rare. I mean, you're not going to see that in a day-to-day use case. But what's wrong in taking a little bit of precaution, right? So that's what we're trying to do. Uh, that's what we're doing here. So we say proto, and then we're defining the HTTPS uh, protocol, and then we're doing another flag that is the transport layer security, and we're using 1.2 because that is kind of like what most servers are um, sort of using broadly these days. You could use 1.3. I think it goes up to 1.5 right now. But 1.2 is just good enough. And then we're doing HTTPS, the website's URL, Rust, sh, or sorry, I think it's Rust. And then um, this is what gives us the web page's output. But if we were to just do this and run it right now, what it would do is that it would um, print the output to our screen. So it would print it to our standard output. SCD um, output is 0. I think it's 0. Yeah, file descriptor is U is reserved for standard input. Sorry, the file descriptor for standard output as 1. Right, so it prints to the one file descriptor, that is our standard output, that is our screen. So that is what this would do. But instead, we wanted to pipe that, the output, pipe that to our shell so that it runs to our shell so that it is able to build Rust locally. And that is how this programming language is installed. Whereas if you were to do something more trivial or something more mainstream, like installing Python, right? Python 3. So you would do uh, uh, sudo, right? Uh, to like establish that you're superior on this computer. You have like the privileges and whatnot. And then you would do sudo, your package installer, and then install is a keyword, um, sudo packet install Python 3. Okay, that is how usually Python is installed, or even something like C, so GCC, right? Um, that is how a programming language is installed. Conventionally, I think you could also install Rust through um, these package managers as well, but then you wouldn't have um, a various Rust functionality. Like I think you wouldn't have Rust up if you were to just install it through a package manager. Keyword versus um, user defined in programming. I forget what this is called. Sorry, I was just thinking of something, and that's what the user, or sorry, check it. Identifier. Right. Okay. So moving on. Let's just do. Okay. So now that we have our hello world compiled and ready, we could just do the next chapter that we were doing um, that uses cargo, and this would be our introduction to cargo. Cargo version. Okay, so that's our cargo version. I don't know what's happening with my tongue. I can't speak, or I can't pronounce like some syllables. Um, I think it might just be the lack of speaking English more frequently here since I moved. Um, that might just be messing up my tongue. I don't know. Uh, anyways, so let's go back. Our world is complete. Now we move on to the second um, project that is Hello Cargo. So note how the first project, Hello World, we did it using Touch, or sorry, we did it using Megger, uh, Hello World. Now we're doing the same thing, but now we're using Cargo, Hello Cargo, uh, and you'll see the difference. Uh, Cargo, new, new, Hello Cargo. Okay, so that creates Cargo. So, so as you can see, um, the difference when we made the Hello World with just the conventional or the conventional way of making a project and going into the project, making a file, and then using that file to compile, using the language's compiler and running it, versus using a predefined tool uh, to essentially make the whole project. Okay, instead of having to like do everything one by one, we are automating that step. And so you could see the difference here. Hello Cargo. So see, this is the Hello Cargo, and this is the Hello World that we made, sort of like from scratch, if you will. Uh, so see the difference. One is already coming predefined with a Git repository. It has its own TOML files. It has its own source files. Okay, so see how cargo is utilized to basically organize stuff. So that is what this tool is doing. This is what this package manager is doing. It's packaging uh, or it's managing our packages. It's organizing our packages, if you will. So let's dissect this. What we have here. Let's go inside. Hello cargo. We go to src, we see the main file, which is essentially another hello world program. See, another hello world program. So anytime we do cargo new, and then anytime we do cargo new and then file name, what it does is that it initializes these folders and these files. And by default, in the source folder, there's gonna be a main.rs that contains the initial template that is just a hello world template. Okay, so right, so now we have that. Um, but we haven't compiled it yet. And let's also look at the cargo.toml. Okay, so toml is what was it? Tom's own markup language or something like that. Uh, it's just a markup language. It's sort of like JSON. Um, I don't know why they don't use JSON instead of like Toml, but they have their reasons, I guess. Um, so it's basically you have a key, you have a value. Uh, okay, and then as you can see right now, we don't have any dependencies. We do have this package uh, metadata or metadata. I never could say it. You guys pick your words over like data and data, but I can't say it either way. So let's move on. Um, so yeah, that's what's inside the cargo.toml. And yeah, Tom's obvious minimal language, not Tom's own markup language. Sorry, I butchered it. Um, Tom's obvious minimal language. So it is like JSON. I don't know why like fucking programmers do. Um, but anyway, good Tom, good Tom. Um, moving on. Cargo has generated a hello world program for you, right? We did that. Building, right? So now we build. So at this point, we don't have anything executable. Okay? So to we have code, but we don't have anything executable. We have nothing compiled. Everything's uh, existing at this point at a high level that has no way to get compiled or that has no way to get executed on the processor. So to do that, previously we used Rust C to compile, but now we'll see that we could just use cargo build. Okay, that streamlines that whole process for us. So we do cargo build, and now if you see, we have a new folder, target. We have a new file called cargo.log. Okay, so what are these files and what are these folders? Let's go and look. If we go and look at the target, we could see that there is a debug. Debug contains our hello cargo. Okay, hello cargo prints hello world. Okay, so that is what it's doing. There is also like in the target um, folder, there's also some more um, essential things needed for debugging tasks that we'll cover on later on. That we'll cover later on. Uh, but for now, what we need to learn is that cargo build is really helpful, and it streamlines a lot of different uh, what do you call a lot of different commands for us. Okay, it automates stuff. Um, okay, so then we did this part as well. If all goes well, hello world should print to your terminal. So that happens. That is happening. And then if you didn't want it to like go in to our target folder like we did here, see, uh, we had to do cd target, and then we had to do cd debug, and then we had to run hello world, or sorry, hello cargo. What we could instead do is just literally go to our folder containing our whole project, and we could just do cargo one, and it printed for us. Okay, see, so fancy. Um, and yeah, so that is what it's doing. Um, Rust also provides like a different utility, so many different utilities. It's just like so good. I just wish it like so my eventual goal, and I hope this happens, is to like be able to modify Rust to use to be put to use to make like machine learning software. Um, but that's a dream right now. That will happen, I'm sure. If I don't, then someone else will, because it is needed in the industry. But I hope I do it first, just because. Okay, anyways, so that covers the second chapter. Okay, then we move on to the third chapter, where we're making a guessing game. So this is where things start to get interesting. Okay. Um, here, C plus nine. Excuse me. Okay. This is where things start to get interesting. Because now we're actually building a program that is able to take user inputs, uh, give outputs, do some processing, give us some introduction to how we could use various dependencies, and yeah, stuff of that sort. So let's create our new project using Cargo. So Cargo new, and then the project name. We're gonna call this, or what are we calling it? Guessing game, CD guessing game. Okay, and then we look at the TOML because it says go look at the TOML. So we go look at the TOML. Okay, this is the package metadata. Um, and then we go and see um, if it runs. So cargo run. The builds compiles. Sorry, it compiles. What's this? Compiles, builds, and runs. Um, so all of that is going on. Well, so now we just make our game, and then um, source main.rs, and we keep the main function right now, but we're gonna use a library now, a library that is already in Rust, and source code, so we don't have to like uh, define it as a dependency, as an external dependency, since it already comes pre-packaged in Rust. We just have to call it. So use stdio. Okay, so that stands for standard input output. So standard input output is a library that enables um, user to interact with the console, um, or with the shell. Um, so that's why we are doing that. And this is well, they do say why the semantic uh, convention is as described here. Um, so I think it's best to read it. Uh, you know what? Let's leave it here. I'll come back. I'll finish this again. Um, I think I should do this um, in a more orchestrated way so that people are able to follow it and not just listen to me blabber and sort of waste that time. I do want to maximize learning, like I said here, maximize learning, productivity, and resourcefulness. So that has to be the goal. Okay. So let's just end the stream here. I hope you had fun. I hope you got to learn something, uh, or some things, I hope. Um, and yeah, I think I'll see you guys again soon. But until then, take care. God bless. Bye bye.